So we're going to talk about exponential expressions, and just for a quick review, we have 5 to the third here. What does that mean? What vocab words do we have to help describe this? This means that our base 5 and our power is 3. The power tells me how many times the base is multiplied with itself. So this means I have 3 5s multiplied together. Remember, exponents are just a way of describing repeated multiplication. So what's the difference here? I have 3 to the power of 2 and 3 times 2. Well, 3 times 2, hopefully you know, is just 6. 3 to the power of 2 means I am multiplying 3 with itself 2 times. So I'm not multiplying with 2. This is just telling me how many 3's I have multiplied together. So that one's 9. Now this one might look the same to you, but it's an important one to know the difference for when you're using your calculator. So you might read these both as -2 to the fourth power, but there's an important little pause in here. This one is -2 to the fourth power. This tells me that I take the number -2 and I multiply it with itself 4 times. Over here, because I have PEMDAS, I need to apply the exponent before I do anything else, and this exponent is only on 2. It is not being applied to a -2 right now, it's only on 2. So first I do 2 to the fourth, which is 16, and then I apply that negative to it. This is really just times -1, but in that very fun math way where math teachers just don't write a bunch of things. This really is a -1 times 2 to the fourth. Over here, this -2 times -2 becomes +4. This one's the same. So now I have 4 times 4 is 16. So if you had intended in your calculator to put -2 to the fourth in, but you did not use the parentheses, it might tell you the answer was -16 when we know the answer really should have been +16. So be careful to use your parentheses when you're putting negative numbers into the calculator. The power of 0. So if 5 to the third meant I was multiplying 5 with itself 3 times, what does 5 to the 0 mean? I'm multiplying 5 with itself 0 times? Like, what is that? We do have 0 5s being multiplied together. So what we have left is nothing, but be careful. There's different versions of nothing in math. And since we're living in exponential expressions or repeated multiplication, we need the multiplication version of nothing. So I have 0 5s, yes, and what that means is I have the multiplication nothing. And what number, when you multiply it with anything, it's not going to change the value of that number. Hopefully you're yelling it out wherever you are watching this video. We also call this the multiplicative identity in math, but it's 1. Because I can multiply any number with 1, it's not going to change the value of that number. A common mistake here is to put in 0, but look out, 0 wipes everything out. It makes everything 0 when you multiply. Adding and subtracting 0 doesn't change the value, but with multiplying, it's going to cause a lot of problems. So anything to the 0 power means I have the multiplication version of nothing, I just have 1. And that's true no matter what number gets raised to the 0 power. You could have very complex things in here, and still, if the whole thing is to the 0, it's just 1. So one last thing before we keep going into the rules. What is 6 divided by 6? Again, I hope you're yelling out 1, because it sure is equal to 1, because there's 1 6 in 6. And that is true for any number divided by itself, it is always equal to 1, and that is going to be very helpful for us. So I'm first going to solve this by expanding 6 to the 4th. Expanding this just means writing out all the multiplication. Is 4 6s all multiplied together? And 6 squared is 2 6s multiplied together. And now look, if you remember your multiplying fractions with, it's never a guarantee, but imagine that you do. I can look at this as a little fraction right here. This 6 divided by 6 is just a big 1. Being multiplied with, I mean, you can always put a 1 in, so this could be 6. And hold on, 6 divided by 6 is also a big 1. Those are just a different way of writing an enormous 1. So what we really have here is on the top, 6 times 1 times 1 times 6. And on the bottom, all I have left is 1s. So I have 6 times 6 over the multiplication version of nothing, which is 1. All my 6's got canceled out. Now there is a shortcut for this instead. When you are dividing the bases, you are going to subtract the powers. And we saw before, right, that this was 6 squared, which is the same as 4 minus 2. But the other reason that you can use to think about this is each number that you have on both the top and bottom can get canceled out. So when you're subtracting those powers, you're saying, I can cancel 1 for each of these ones shown here. I can't cancel more than that, but I can cancel these 2 out of the top. I do want to also note, if we had 6 to the 4th over 6 to the 7th, notice that up here, I mean, I just wrote 6 to the 4 minus 2 is 6 squared. These were really over our multiplication version of nothing. They were over 1. Here, when I do this same rule, 4 minus 7, and I get -3, that answer has to stay in the numerator of my fraction. This is still over 1, just like it was up here when I have that -3. We will learn what to do with that -3 in just a moment, but when you are just using this shortcut and just subtracting, leave it where it is. So now that we're multiplying bases, we'll do the same thing. We'll expand first. We'll learn the shortcut. I've got 4 7s here, multiplied with 3 7s here. Everything's being multiplied together. I just look and see how many 7s I have. There are 7 of them. You could maybe predict what the shortcut rule is going to be. We are going to add our powers together when we are multiplying the bases. So just to do a quick practice, I've got some 6's here. I can't smush them together with the 7s, but I can rearrange this. Since 2 times 3 is the same as 3 times 2, right? I can rearrange these here. And then I can combine my 6's. That's 3 6's and 4 6's is 7 6's. And you don't have to write out the rearranging step. I'm just doing it to help you see it visually. Here, we could start by simplifying this way, or we could start by simplifying this way. It doesn't matter. We're going to have to do 2 steps anyway, but you do whatever you like best. I'm going to start with simplifying the top. I have 3 7s and 2 more 7s is 5 7s. On the bottom, I have 4 7s. So 4 of these are going to cancel out 4 of these, and I will have only 1 left over nothing, the multiplication version of nothing, which is 1. So this is really just 7. And here, I'm going to rearrange again just for my visual. You don't have to do this for you, to get my 5's together and my 3's together. So on the top, I can see I have 5 5's and 2 3's. And then I have 4 5's and 4 3's on the bottom. Now I am going to show this with expansion first, and then we'll come back and look at it with shortcuts. Yes, I have to write out all of these. See, this is why we don't do it usually, but I think it's helpful sometimes. So every 5 that's on the top and bottom, I can cancel. 1 of them, 2 of them, 3 of them, 4 of them. Same thing with my 3s, 1 of them, 2 of them. Those were all big invisible ones. So I get left with a 5 on the top and 2 3s on the bottom. If you instead were doing the shortcut rule, we would subtract my 5s. 5 minus 4 leaves me 1. And we would subtract our 3s. 2 minus 4 leaves me -2. And we haven't yet done negative exponents in this video, so hold on tight for that one. Now, a power to a power. This 2 tells me I'm going to multiply everything in the parentheses with itself twice. So I have 3 to the 4th times 3 to the 4th. And that means there's 4 3's here and 4 3's here. Well, that's 8 3's altogether. Can you tell what the rule is? Here's another example to help see it just in case. I have everything in the parentheses multiplied with itself 3 times. So I have 3 to the 5th times 3 to the 5th times 3 to the 5th. 5, 10, 15. I have 15 3's. The rule for a power to a power is you are multiplying the powers.